Good day, grade 7.
I am your teacher, Marie.
Good day, grade 7. Now we're going to discuss a new topic. Let us enjoy watching while learning.
Okay, so last time we have discussed the linear equation in one variables. And now we're going to discuss is the linear inequality in one variables. So when we are working inequalities, we can usually treat them similarly to two, but not exactly as we treat equalities. So we can use the additional property or addition property and multiplication property to help us solving them. The one exception is when we multiply or divide by a negative number, doing so reversed by inequality symbols. We multiply or divide an expression and we have the negative numbers, so we're going to reverse the inequality symbol. So there are three ways to represent solution to inequalities. First is an interval, a graph, and an inequality. So because this is usually more than one solution or an inequality, we can check your answer because this has usually more than one solution. And inequality, when you check your answer, you should check the endpoint and one other value to check off the inequality or the solution. When we work with inequality, we can usually treat similar to, but exactly as we treat inequality. We have treat equalities. So how do we solve linear inequalities and express a solution with intervals notation and inequalities? So let us proceed to our discussion. We have the linear inequality in one variable. So in the previous chapter, equation is defined as mathematical sentence indicating the two expressions are equal. So when a mathematical sentence is indicated that the two expressions are not equal, then it is called inequality. A linear inequality is like linear equation, but the equal sign is replaced with an inequality symbol. The relation symbol we have is less than, greater than, less than or equal to, greater than or equal to, and not equal are used to denote inequality. So here are the below of some example of linear inequalities in one variable. Number 1, x minus 1 is greater than negative 4. Number 2, we have 3 plus y is greater than or equal to 1. Number 3, 2x is less than negative 5. Number 4, we have x squared is greater than or equal to 0. And number 5, we have negative 2 all over x squared plus 2 is less than 2. Linear inequalities number 2 and number 5 in the given examples above are the unknown as absolute inequalities. The inequalities are usually true when x is replaced by any real number. Linear inequalities number 1 and 3 in the given example again are conditional inequalities since they are true only when we have a specific value of the variable x. So linear inequality can be written in the form of ax plus b greater than 0 where a and b are real number and a is not equal to 0. So in inequality symbol, the greater than can be replaced with another inequality symbol such as less than or equal to, and greater than or equal to, so that we have the form in linear inequality. Again, in the linear equation in one variable, we have exactly one linear equation form. We have ax plus b is equal to 0. But in linear inequality, we have four form in writing the linear inequality. We have ax plus b is less than 0, ax plus b is greater than 0, ax plus b is greater than or equal to 0, and ax plus b is less than or equal to 0. They are also inequalities. So we have the 4. So here we should be remember So when we have both sides of an equality are multiplied by a negative number, the sign of inequality is reversed. So if we're going to multiply the expression with a negative sign or negative numbers, we're going to reverse the negative sign or the given inequality symbol. So we're going to rechange. So if we have the greater than, then it will be less than. So there are no subtraction and division properties. Subtraction can be expressed as the addition of the negative of the subtrahend to the minuend, and division can be expressed as multiplication of the reciprocal of the number. So we have the solving linear inequalities in one variables. So the solution in an inequality is in the set of real numbers that make the inequality true with the aid of the properties of inequality. So we can solve linear inequalities in one variables. So let us consider the given example of the linear inequality. Number 1, we have 5x plus 15 is less than 40. So we can rewrite it as 5x is less than 40 plus negative 15 by addition property of inequality. Then 5x is less than 25 because we have 40 plus negative 5. Subtract the 2 because we have the unlike term. So 40 minus 15 is 25. Get the sign of the highest number. We have 40 and the sign of highest number, which is 40, is positive. Therefore, we have positive 25. Then multiply the two expression or multiplying property of inequality by 1/5. So we have to make it the expression or the variable x be one of the coefficient, or the coefficient of x be 1. So we have 1/5 times 5. 5x is equal to x. Then 25 times 1/5 is equal to 5. Therefore, we have x is less than 5. So to graph the solution set or the solution set that we have, because in inequality there is a solution set. Okay, so we have x is less than 5 if we're going to graph it. So in the positive 5, it is a hollow point or it is not solid point. So then all integers in the negative sign or the negative integers, they are also a solution of the given inequalities. Okay, number 2 example, we have 4x plus 3 is greater than or equal to 19. So we have the addition property of inequality and multiplication property of inequality used in solving the given linear inequalities. Well, 4x is greater than or equal to 19 plus negative 3. 4x is greater than or equal to 16, and we have 4x times 1/4 is equal to x. Then 16 times 1/4 is equal to 4. Therefore, we have x is greater than or equal to 4. So the solution that we have is from positive 4 to the highest number. So our solution here, it uses the solid line, because if we have the greater than or equal, we're going to use a solid line or solid that. Then to always remember, if we have this the greater than or less than, it means we have to use the hollow point, or the solution that we have. If we have like in the given example number 1, we have 5. So number 5, the integers 5 that we have, the positive 5, is not considered as a solution. So the considered solution that we have is less than 5. So because we have the x is less than 5, therefore the solution set is less than positive 5. So positive 5 is not part of the solution. That's why we have used the hollow sign, or the symbol. The point is not solid. Okay. Next, in number 2 example, we use the solid point or solid dot, because in the given solution that we solve, we have x is greater than or equal to 4. So 4 is we have x is equal to 4. So 4 is part of the solution. Therefore, 4 up to positive integers or the greater than 4 is part of the solution. Okay? So 4 from greater than 4 is a solution of the given linear inequality that we have. So next, example number 3, we have 3x minus 5 is greater than or equal to 5x plus 3. So we're going to use the additional property of inequality and multiplication property of inequality. So we have 3x minus 5 plus 5 is greater than or equal to 5x plus 3 plus 5. So 3x is greater than or equal to 5x plus 8. Then we have 3x plus negative 5x greater than or equal to 5x plus negative 5 plus 8. Then we have negative 2x is greater than or equal to 8. Multiplying by negative 1/2. So here we're going to reverse the signs that we have or the symbols of inequality. So we have x is less than or equal to negative 4. So our solution set is here. So from negative 4 to less than negative 4 is part of the solution or a solution set of the given linear inequality. So the set of all solutions and in linear inequality is called the solution set of inequality. So the solution set may be represented on the number line. So we have to represent the solution by graphing on the number line. And linear inequality is graphed as interval, array, or a line, included the endpoints and shows by that. So the endpoint is the dot, while the ending points that are not included is the solution set. Then we shows the hollow circle. So we have the hollow circle if the endpoint is not included. So we can use the hollow circle if we have the greater than or less than. But if we have the greater than or equal or less than or equal, we're going to use the dots, okay? Or the solid circle. So when two inequality are combined, like in the given example number 2, only one statement or the result is called the combined inequality. The word and or are used to describe the relationship between the two quantities. So consider the graph of the solution set of the compound inequality. So here is the use of and or in the given linear inequality. So we have negative 5 is less than x and x is less than 3. So we're going to have the solution. So negative 5 is less than x and x is less than 3. This inequality may be written as x is less than negative 5. Then this inequality may be written as x is greater than negative 5 and less than 3. So if we're going to graph it, we have negative 5 is less than x. So this will be the graph. And then the graph of x is less than 3. Then if the compound inequality, this will be the graph of the 2. So we have the interval. The interval is negative 5 and positive 3. Then we use the hollow circle because we have in the given inequality that we have used is the symbol is less than. Okay? So we're going to use the hollow circle. So the solution are the values between negative 5 and 3. So negative 5 is less than x and x is less than 3 in the given example of the conjunctions. How about or? If we have or, so this will be the given. So same given po tayo, we have x and x is less than 3 and x. Now they're going to use is or. Okay, so here is the symbol. So we're going to have the two quantities and the use of or. So we have x is less than 3 or x is greater than or equal to 5. So here is the solution. We're going to graph the x is less than 3 and x is greater than or equal to 5. So the graph of x is less than 3 is here. So we have used the hollow circle because the inequality that we have is the inequality symbol is less than. Then we have the x is greater than or equal to 5. So we have used here is the dot or the solid circle because we have the greater than or equal to symbol, okay, or the equality symbol. So here is the graph of the compound inequalities. So from negative, we have the positive. The solution consists of the value that lie on the left of 3 and to the right of 5, including the endpoint at 5. So that will be the solution of the two inequalities. So x is less than 3 or x is greater than 5 is an example of disjunction. So the other one, if we have used and, this is conjunction because combining the two inequalities. While if we have or, so we have the disjunction because our graph separated it, okay? So this will be how to remember. So the compound inequality involving and has the solution that satisfies both the solution of the two inequalities involved. This compound inequalities is called the conjunctions. The inequality is true only if both inequalities are true. The compound inequality involving or has the solution that satisfies at least one of the solution of the two inequalities. This compound inequality is disjunction. The inequality is true if either of the two inequalities or both inequalities are true. Now let us have an example. So solve the following inequalities and graph their solution set. So we have 3 is less than x minus 3. So here is the solution by the use of additional property of inequality and simplify. Okay, so we have 3 is less than x minus 3. So by the use of additional property of inequality, we have 3 plus 3 is less than x minus 3 plus 3. So we have 6 is less than x. Therefore, we have x is greater than 6. So just we're going to have the variable to the left side of the inequality sign in the given final answer. Okay? So here is the graph of the solution set. We have used the hollow circle because in the inequalities that we have, we use the greater than symbol. Another example, so number 2, we have 2y is greater than or equal to 16. By this of multiplication property of inequality, we have 1/2 times 2y is greater than or equal to 1/2 times 16. So we have y is greater than or equal to 8. Then we have the graph. So here we use the solid dot or the dot or solid circle because 8 is including in the solution set. Number 3, we have the two quantities. So we have negative 2 is less than or equal to 2x plus 10 and 2x plus 10 is less than 16. So we're going to have solve the inequality separate and combine the result to form the compound inequality involving the conjunction and. So here we use the and, okay? So we have the solution of the two and the graph of the two inequalities that we have. So here is the solution that satisfies both x is less than 3 and negative 6 is less than or equal to x. Then the representation of the portion where the two graph overlap. So that will be the graph or the solution set of the given, or all the values of x will be the solution of the given linear inequalities in number.
Thank you. Enjoy watching while learning. This is your teacher, Miss Marimar F. Figalan.